Have you ever used a smart assistant on your phone, or seen your email finish a sentence for you? That's the work of a language model. Think of it as a very clever computer program taught to understand and use human language. It's not alive, it doesn't have feelings, but it has learned the patterns of how we talk and write. It's like a student who's read almost every book in a gigantic library. This student can't think for itself but is incredibly good at predicting which word comes next. It does this by studying massive amounts of text, books, websites, articles, learning connections between words. The main job of a language model is prediction. When you type, "the sky is," the model predicts the most probable next word, usually blue. It's all about probability guessing based on experience. The model has seen "the sky is blue" millions, maybe even billions of times during training. That helps it generate natural, human-like sentences. It can answer questions, translate languages, write stories because it learns statistical relationships in our communication. Now, what makes a language model large? It's not about the physical size of the computer it runs on, although that is also a factor we will get to. The large language model, or LLM, refers to two main things: the sheer number of adjustable knobs it has, and the gigantic size of the library it read to learn. Scientists call these adjustable knobs parameters. A small model might have a few million parameters. That sounds like a lot, right? But a large model can have hundreds of billions, or even over a trillion of them. Each parameter is like a tiny decision-making point that the model can tweak during its training. Having more parameters allows the model to capture much more subtle and complex patterns in language. It can understand not just words, but also nuance, sarcasm, and intricate relationships between ideas. The second part of large is the training data. This is the text the model learns from. A small model might be trained on a few gigabytes of text. A large model, however, is trained on a dataset that is almost unimaginably vast. We're talking about hundreds of terabytes of data, a significant portion of the entire public internet, digitized book collections, and scientific papers. This immense volume of information gives the model a comprehensive view of human knowledge and communication styles, from formal academic writing to casual online chatter. It learns grammar, facts, reasoning skills, and different languages from this data. So, what's the actual difference in performance between a small language model and a large one? It's like comparing a pocket calculator to a supercomputer. A small model, with its fewer parameters and a smaller dataset, is great for specific, narrow tasks. For example, a model designed to run on your smartphone to predict the next word you type doesn't need to know the history of the Ottoman Empire. It just needs to be fast and efficient at basic sentence completion. Ask this smaller model a complex question that requires reasoning, and it will likely struggle. A large model, on the other hand, is a jack of all trades and a master of many. With its billions of parameters and vast training data, it can switch between tasks seamlessly. You can ask it to explain quantum mechanics, then immediately ask it to write a poem about a cat, and then translate that poem into French. It can reason, infer, and even exhibit surprising creativity because its internal network is rich enough to make complex connections. While parameters and data are the stars of the show, there are other large factors at play: the hardware required to train them, and the time it takes. You can't train a model with 500 billion parameters on your home computer. It requires a colossal amount of specialized computing power. Training a large language model can take several months of non-stop computation, even on massive hardware. The energy consumption is enormous, sometimes equivalent to that of a small town. And the cost runs into the hundreds of millions or billions, which is why only a few organizations can build them. In short, large parameters, large datasets, large computers, large energy bills, and large amounts of time combine to create something powerful. This scale is what lets LLMs move from simple predictors to versatile tools that augment creativity and intelligence. Understanding this scale helps us appreciate how far AI has come and where it might go next.